Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled The Elephant's Trunk in Cepheus. So what do we see here? Well, here looking in the northern sky, we see what is known as the Elephant's Trunk Nebula, which may have the resemblance of the long trunk of an elephant stretching across the sky as we see here. Now, this region is actually part of a star-forming region, and we see especially the dark nebula here, the very dark, dusty areas, which are the most active regions of star formation. That is where star formation is going on right now. However, it's hidden from our view because of dust. Dust in space is small particles, little bits of material smaller than typical household dust, but still enough of it spread across large distances that there can be enough particles blocking out your view of inside. So what's going on here? We can't see it because the visible light can't get out. There is just too much material. Think of it as trying to look through a wall. Or maybe more appropriately, trying to see a clearing from the middle of a forest. No matter where you look, your line of sight will strike a tree, and therefore you can't see out of it until you get close enough to the edge. Now, one thing we can do with dark nebulae is to look at different wavelengths. So the dust does absorb light, but it is much better at absorbing and scattering the very short wavelengths, the blue light and the green light, which have shorter wavelengths than longer wavelength red light. So when you look at longer wavelengths, you get a better chance to be able to look into the nebula. Now, in many cases, if there's enough dust, even all of the red light will be absorbed. But there are longer wavelengths. The electromagnetic spectrum does not stop at what we see. You can actually go beyond that. In this case, it would be infrared. And in many cases, infrared images of these will give us a peek into the star-forming region that is going on and see the stars that are forming within these dense clumps of material. So we can begin to see those which are known as protostars, just beginning to form. And if we could wait a little while, maybe 100,000 years or so, they would start to burst out of their cocoons where they're hidden right now and would actually then be visible. And we can kind of see maybe a little bit of that happening at the very top up there, where there's a little bit of a hole within the nebula at the top. And that can be a star that is starting to break out and energize enough that it is starting to clear out that region. Now, the red glow we see around would be the red glow of hydrogen gas. Hydrogen, when energized, will give off a very specific wavelength in the red. So that is very different than the absorption that we are seeing by the dust. But that is what is called emission. When a hot star ultraviolet light excites the gas, then it can be caused to glow, such as we see in tubes here on Earth. When you send electricity through them, that energizes the gas atoms and causes them to glow. Here we see the same thing on a much larger scale in space. So that was our picture of the day, titled The Elephant's Trunk in Cepheus. We'll be back again tomorrow for the next picture. So until then, have a great day, everyone, and I will see you in class.